So yeah, we were talking about equals, and oh, that's the lab. Let me go find, where were we? Objects review. We didn't quite finish talking about equals, but I'm going to go quickly over equals again. All right, so equals on objects. Whenever you use equals, it's comparing the contents of the actual variables themselves. And you got to remember, when we have objects, our variables don't contain objects. They contain references to objects. So when you use equals on two reference variables, it checks if the contents of those reference variables are the same. Effectively, if you've got the exact same reference. Like literally, if you've got the same reference, meaning like you have aliases, meaning you have two references to the exact same object. And in this situation, we call that equals sameness. They're literally the exact same thing. It's not that they're equivalent, it's that they're the same thing. So when we actually want to check if two objects are equal, we have to tell Java what it means for two objects of that type to be equal. By default, it's not going to know. And you might say, well, check if all the fields are the same. Sure, maybe, but that might not always be what you want equals to mean for your particular situation. So whatever you want it to be, you write that code. And here's an example, a very simple, straightforward example. That doesn't mean it's trivial, but it's a straightforward example of what we really want to care about is if their fields match. If the friend objects have the same first name, last name, and email address, then we'll consider them the same. But there's a lot more going on in this equals than just that. What I just explained was that last bit there, lines 74, 75, and 76, which is really just one line of code, but I broke it up into multiple lines. So whenever we're checking equality on an object, because everything in Java is strongly typed, we want to be able to ask an instance of an object, are you equivalent to anything? We want to know if it's equivalent to any arbitrary thing. So we say that the parameter is of type object, and everything is an object. If you're making a friend class, it's also an object though. If you're making a course object, it's still an object. So everything's an object. And we start by assuming all we have is an object. Then we say, okay, before we even really dig, check sameness. If O and this are literally the exact same thing, they're equal. No need to dig any deeper, they're just equal. Say they're equal and be done with it. Make sense? The next thing I say is, okay, is O null? If O is null, then this isn't equal to it, because this exists. If I'm able to say some object dot equals, the this must exist. If O doesn't exist, well then they're not equal. Something that exists doesn't equal something that doesn't exist. So no need to dig deeper, it's just false. Then I check, and this doesn't always have to happen, but in this particular example it makes sense, but this isn't always what you're going to want. The next thing I check is this.get, so okay, I say O.getClass. That'll return what its class is, its most specific thing. So if O happens to be a reference variable to a friend object, that'll give me friend. And then when I say this.getClass, well, this is always a friend, so it's going to be friend. I'm checking, do their classes even match? If O isn't a friend, if O's class is course, and this is class is friend, they're not equal. A course and a friend, they're not equal, it doesn't matter, move on. But if they are equal, meaning we make it past that if statement on line 69, we jump down to line 73. I just concluded that O is a friend class, is of type friend. It is. It's also an object, but more specifically, it's a friend. And because of that, we can cast that what O is referencing as a friend, and we create a friend reference variable called other that now is a reference to a friend class. And because Java is now happy that it is in fact a friend object, I can say things like other.firstname, other.lastname, and I check that they're all equal. you might notice, well, hold on. There's a lot of things you might notice here. And there's a lot to unpack here. And I'm not expecting you to be experts on this after I'm done talking about it, but I'm expecting you to be aware of these things so you can figure it out later. One of the things you might notice here is I'm saying first name, this dot first name. Cool, makes sense. First name is a field. But I also say other dot first name. But the first name field was set to private, right? So why is it that I can access some other object's private field from outside that instance? Well, private actually means anything of this class can access it. So it's entirely safe here, FYI. Another thing you might notice is I'm using objects dot equals this dot first name comma other dot first name, right? Like, let me show you what I mean. So I believe I have this here. Well, maybe I don't. I'm going to copy this equals. Cool. Yeah. Got to import that class. Actually, I'm going to come back to this point. The next thing I'm going to talk about is a hash code. I'm going to explain all this. I'm going to come back to this in a moment. When implementing an equals method, we should also always implement a hash code method that goes along with it. We're not going to go into details about what hash code really means and why we love it and everything. We're not going to explain that. I've kind of explained it before. It's an important idea when it comes to like dictionaries and sets. It's the idea that we want to be able to take some object and convert it into a number. And the goal is all objects that are equal should get mapped they must get mapped to the same number. If you took two things that are equal and we use hash code on them, we should get the same number, like we got it. And ideally, we want unequal objects to give us different numbers. Now that's not technically always possible, but in practice it's often fine. But the goal is, with hash code, convert some object into a number. That's what we want to do. Now, a lot of times with very simple objects, our hash code is just going to like hijack the various fields hash code in some combination. Long story short, for our very simple classes, are things like a friend or a course or a country. These are simple classes. Our hash code is going to look basically exactly like this. And what this means is we're going to take the hash of first name, last name, and email, because those are strings. And strings actually already have the hash code method implemented. So just use the strings hash code and put them together to make a new one. That's what we're going to do. So I'm going to copy this over. Cool. So now I'm pretty much all set. I'm going to go to here to lab 2. I'm going to make 2 friends. Here. Okay. If I want to check, I'm going to show you an example of equals equals versus the 2 ways we can call dot equals as well. So we can see that my friend and my other friend are equal by how we defined equal in the equals method. But we know that, okay, all their fields match, they're equal, right? And if you go and you say, my friend equals equals my other friend and I hit run, the answer should come back false. Because although they're equal, the two reference variables, my friend and my other friend, are actually they're different. They are not the same. They are referencing two different objects. They're false. But if I change it to another friend, this will come back as true. Because another friend is referencing actually the exact same object. They're aliases. Any questions about this so far? Ask now before it's too late. Okay. So you'll notice in here, I'm calling objects dot equals. But you know, this method equals exists in the friend class. So I should actually be able to call equals on an instance of a friend. And you're absolutely right. I should be able to say dot equals my other friend. And I can. This is going to work just fine. It's true. They're equal because they are. When I asked my friend, are you equal to my other friend? Well, this is first name, and other's first name were the same. This is first name. And in this context, this would be an alias for the my friend reference variable, and other would be an alias for the my other friend, right? If we were to go to the equals method, this would correspond to the instance it was called on, and other would be what was passed as the argument, right? Good? Yeah? So this is good. And this right here is like your standard way of calling equals. Pardon me. I'm pretty congested, so if I keep having to deal with it. So this is fine. And let's show you an example. I'm just going to put the literal hello in here. It's going to work just fine. Hello's class is a string. My friend's class is a friend. Friend and string are not the same classes, so it's false. In fact, specifically, it's this false that got returned because the classes are different, right? Let me go back to here and say, if I were to, like, my friend, I'm asking, like, I'm giving it the same thing. So this should be true because the first if statement should trip. If it'll run. True. Why? Well, when we go look at the friend class, that's the oh and this are literally the same thing. That's the true that gets returned. Because my friend and my friend, they're the same reference variable. So this would be the my friend, and other would also be the reference variable, my friend, so they're all the same. Yeah? So are you happy? I'm seeing some faces of people that look unhappy, and if you're unhappy, just ask a question, because I don't know, I can't read your mind. All right? And finally, if it just so happened that, like, let's say my other friend was null, this will say false. Why? Well, let's go look. That would be this one. O is a reference variable to null, meaning they're not equal, so we return false. And it was this false on line 46 here that we're actually seeing, like, right here. Get printed out. Yeah, we're all happy. I'm sorry. But we got a problem. There is one issue with this particular situation, and the issue is actually a pretty big deal. And it's the ultimate reason why we use the objects dot equals. The issue is this is not null safe. Meaning, imagine this line of code was in some function somewhere that got some parameters. And I don't really have control over what those arguments that are ever passed to the function is, right? So if that's the case, it's entirely possible that, let me go back and so my other friend, I'll do this. So at this case, they should be equal. And we saw what would happen if like the parameter was null. But what happens if this is the case? Okay? The reference variable, my friend, it's a friend reference variable. So the reference variable knows because its class is friend, I should be able to ask it, are you equal? And it would call the friends equals method. But we got a problem. What is my friend really referencing? Nothing, null. And when I hit run on this, does anyone know what I'm going to see? A null pointer exception. Because I asked my friend, exception, null pointer exception. It's because I asked my friend if it's equal to something, but my friend is nothing. So I asked null, hey, are you equal to something? And null goes, what the hell? I'm null. That's not a thing. Whenever you have a reference variable that references null and you tell that reference variable to do something, you tell that instance to do something via the reference variable, but it's null, you get a null pointer exception. That's what happens. When you have a reference variable that references null, but you thought it, like you tried to act like it wasn't. That's what a null pointer exception is. You got the same thing in Python, except it was something about like can't ask none type to do whatever, right? So this is a null pointer exception. But this isn't that unreasonable of a request when you consider like, well, okay. If I were to just change the order of these things, my other friend and my friend, when I run this, I get false, right? Because a friend is not equal to nothing. But as you know with equality, it doesn't matter which side is on, like which value is on which side of the operator. A equals B is got to be the same as B equals A. But that's not what's going to happen here. I just flipped them, it says false. If I flip them back, I get null pointer exception. They're not equal. We've got a problem. This is a null safe situation. So what we do in these situations is we make use of the objects. Not object, objects. There's an S because it's full of static methods, functions. And inside of the objects classes, there's a lot. Now, we don't make an instance of an object class. It's just full of static methods, so we just say the name of the class and then the function we want from within it. And I want equals. And in this case now, if I do my friend, my other friend, I should get back false. The order won't matter anymore. It's null safe. And if you're wondering, well, how does object know what to do? Well, it's actually quite clever. It's quite nice. In fact, we can click it. We can click this and go directly to the objects class. In fact, if I go back here and say objects.equals, if I click that, it'll actually take me directly to the equals method that Java gives you for free. I didn't write this. It was just there with Java. This is the static equals method inside the objects class. And what do we see? Well, it's equals. It returns a Boolean. It takes two things of type object. Great. And the first thing it does is it checks A equals B. What is that doing again? Sameness. It checks sameness. If they're literally the same thing, just stop looking. You don't need to check any further. They're equal. Or, and remember, this is a short-circuited OR, meaning that if that is true, it doesn't need to evaluate the right-hand side of the OR. Right? Just stop. You're good. But if it's not true, well, it needs to dig a little deeper. And we have two things there. We say, well, does A not equal null? If A doesn't not equal null, meaning if A is null, that'll be false. And we have a short-circuited AND. So if A is in fact null, what will this return? False. Right? Because false and I don't care what. Right? And then finally, so this is written in a nice like Boolean expression, but we could have done this with like several ifs and it may have made it a little bit more easy to understand for new programmers. But basically, if they're the same thing, return true. If A is null, return false. And then finally, If they're not the same thing and A is not equal to false, we say A dot equals B. Well, when I say A, if A is of type friend, of class friend, when I say A dot equals, it'll call the friend class's equals. So this will finally, after all is said and done, will call the friend class's equals, but it checks if A is null first. And this is the workaround for that funny situation of, well, what happens if like this was null? And that's how we do it. And this is the null safe way to do it. I don't have to do it that way, but if I don't do it that way, it's really not great because it's not null safe. The same goes with hash code. I can call the string class's hash code directly, but what if this was null and then I try to call hash code on something that doesn't exist? We'll have a null pointer exception. So we call the object static version as well. So that's why we do it like this. Any questions about that? Yes?
How does the double and work?
Basically it means, and the same thing works with double or, like the two pipes, right? If I ask you, am I wearing shoes, or do I even need to finish the sentence? No, you know it's true because a true or anything else is always true. The same thing works with and. So if I say, am I wearing a hat, and you don't even need to know what else I'm going to ask. If I'm not wearing a hat, it's false and whatever. False and whatever is always false. So as soon as, when we use double and, it's the short circuit version, which means if I can conclude that the whole statement's going to be false without even looking at the right-hand side, just don't look at the right-hand side.
Okay, so if it's not null, it just immediately,
If it is null, it immediately stops, and it doesn't even consider the A dot equals B.
okay.
Yeah. Now, I've talked about this before, but I'll say it again just in case, because it is kind of funny. There are cases where you might not want a short-circuited and or. There is. It's not particularly common, and it's going to be very uncommon with the way I've been showing you to program, things where you don't have side effects and whatnot. But if you have a very side effect heavy program, where calling a function makes a change somewhere else in your code, like to a value that's really important, and it's a side effect, and but that function returns a Boolean that you've got in your Boolean expression, so it needs to run no matter what to have that side effect that you need, well then you would not want the short-circuited version. And if that didn't make sense to you, don't worry about it. You basically almost always want the short-circuited version with how we've been programming. But technically, maybe in some funny case, you wouldn't. Yeah? Yeah? And if you're not convinced about how that works, you can do it yourself by basically writing functions with side effects with prints in them, and just change the order that you call them, and you can see what happens for fun. Other questions? All right. So creating instances, already showed you that. And remember, inside the variable is actually not the object, it's a reference, right? I've been ranting about this, right? Just like that. References, right? So here, if after this code I have a friend and b friend, but then immediately on line 4 I say b friend equals a friend, this friend loses its reference variable, right? So in this case, what happens to the sad little green man? The garbage collector comes along. So in older programming language, not older, in other styles of programming languages that don't have automatic garbage collection, which means when you have something in RAM, but there's no way to get to it anymore, if that happens, you have what we call a memory leak. Your program is taking up some memory that it doesn't need anymore, and that's bad. And if your program is running a long time and it keeps taking up more and more and more memory, we're going to have a really big issue, right? But in some programming languages, there's something called automatic garbage collection, where there's this process that runs, and it goes like, okay, well, that sad green man, nothing references it, meaning no one can get to it anymore, meaning it's useless, meaning just free up that RAM. It's complex how the garbage collector actually comes and runs and does its thing, but it's not important for us. So anyways, the green man is as good as gone. Or in this case, I guess it was Jane. But anyways. All right. And again, you might feel like this works different with primitive types. How, well, primitive types, you know, when I use equality, it just worked. It told me the values were the same. Well, what's different is what was stored in the variable. Not how the various operators around it work. It's what's actually stored in the variable was different. Right? When I said B friend equals A friend, I didn't make a copy of Jane. I copied the contents of what was in. Or sorry, I guess I should have said I didn't make a copy of Bob and then have B friend reference the copy of Bob. No, I copied the contents of A friend, which was the address of Bob. Questions, 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 questions. Yes?
In this friend class, is the hash code even used at all? Because it just makes the hash code for the specific in an instance of a friend object, but in our equals method, we just compare the different fields.
It would get used in the tests, but that's kind of like contrived. It wouldn't really matter for us. But in order to have equals written correctly, we really in order to implement equals the most correct way, we should have hash code implemented as well, even though we're not really using it directly.
Would we ever want to use just the hash code in the equals method instead of just comparing all the fields?
No, that would be, I feel like that would be cheating. And it would ultimately mean that you could have an unsafe hash or not really effective hash code, right? The only place that hash code is going to get used with this particular class is if we start to write a hash code for a class that contains friend objects that need the friend class's hash code.
I guess using the equals method would encapsulate.
It definitely would be, I feel like it could enable you to make a less good, not necessarily. I feel like we could really flesh out this conversation, but we really don't need to right now. Interesting question nonetheless. Other questions? Is that a question back there or just a stretch? Just a stretch. Okay, next. Unit testing. So, like we remember from Python, we got to test all our code. Writing the code and hitting run and seeing that it works is not good enough. You have to test it. And you have to write the tests and show that they pass to convince anyone that your code works. If you show me code and you're like, is this right? I go, did you write the tests? And you go well, just tell me if it's right. And I go, write the tests. It's not my job it's your job to convince yourself and everyone else that the code you wrote is correct. That's your job. And I don't just mean in this class. I mean if you write code, that's what you do, right? You got to have your unit tests. And if anyone ever tells you you don't need them, don't listen to them. You should not listen to any word that comes out of their mouth after that statement because that's not good. You always have to write your unit tests. The good news is the way we're going to write them is basically the same as we did it in Python. But we have to use slightly different tools and technologies because we're using Java. But the idea is the same. We write tests to test individual functional units in all the various cases we can think of, and then we're happy if everything passes. So, the testing was far from thorough. Oh, yeah. So what I'm saying here is, yeah, we made some instances, called some various methods on them, and they seem to run properly, but that's not a very rigorous testing. So what we want to do is we want to use unit or component testing. So we want to do unit testing with good coverage. Coverage meaning our tests are written where we cover all possible scenarios with our code. When doing so, individual test methods are written to test the unit's components. These tests can also be run automatically. This is good. What's really nice about unit tests is I wrote my code, I wrote my tests, right? And if the test passed, it tells me the code's good. But what's nice is code is usually not very static. It's going to change over time a lot of times. So if you wrote this big class and all the tests pass, and you come up with a slightly improved way of solving some problem with that code, and you change it over here, you already have the tests written. So if you make a change and the tests still pass, great. If you make a change and the tests fail, uh-oh. But it tells you where the problem is. And the good thing about these unit tests too, if they're written really well, when a test fails, the test that fails should be really indicative of exactly where the issue is. It should say, test failed when you did this. Oh, okay, so when I did that, something went wrong. I should go look at that. It's great. So the tests are fantastic. It's insane to me how many times new programmers, and I'll say y'all are a really good bunch. The statement doesn't really apply to you. But new programmers miss the mark. Where, like, if you're in like a math class and you work through the process and you get an answer in the end and you go like, I hope I'm right. I don't know. Maybe I can compare what other people got. But right, you know, I get the problem description, I work through the process, and I get my answer. Here's my answer. I hope I'm right. With programming, it's great. You can just test it. You can know if you're right or wrong before you ever hit submit on your assignments. It's fantastic, right? It's a good thing. We like this. Okay. Now I will say the last statement here is very true. Writing tests, sure, there's a systematic way we go about doing it, but at the end of the day, especially when we start to get to more complex class, a simple class like a friend class really isn't too bad. But once we get to more complex classes, writing tests can be a little bit more of an art than a science. So this is a skill that you develop with more experience. But, yeah, we'll see. So, let's say I've got my friend class, right? And do I have another instance open? I do not. This is perfect, perfect. I've got my friend class, and I want to write unit tests for it, right? Because right now I don't have any unit tests. I want to write unit tests. And in order to write unit tests the right way, we're going to go through a bit of a couple of hoops we got to go through. Now, every IDE is going to be a little different. I'm showing you how it works in IntelliJ. If you're not using IntelliJ because you prefer some other one, chances are you're already kind of familiar with that IDE anyway, so you can figure it out. But I'm showing you how it works in IntelliJ. So here's what I'm going to do. You'll see over here I've got this like SRC folder. That's for your source. All right? Typically, what you're going to do is you're going to go and create a new folder, directory, called test. And that's where your tests go. So inside source, you will see all my source code. But I'm going to go up to here. I'm not right-clicking on source. I'm right-clicking on like the folder that source is in, which is the name of the project, which is called Java Playing. I right-click, new directory. And I'm calling it test. I don't need to call it test, but you call it test. Right? I'm telling you, you don't need to call it that because technically you can call it whatever, but if you don't call it test, you're weird. Don't be weird. Call it test. All right. Now, technically, I believe this is good enough, but what we're going to want to do is tell IntelliJ that, okay, this folder here is actually a special folder. This folder or directory is where we're going to put the tests. So what we do is we go and we right-click on this folder. There's a couple of ways we can do it. This is the easiest way. You right-click on the folder. You go down to mark directory as test sources root. There. And it should turn green. See, it might be hard to see. See, it's green. Yeah. That's where we're going to put our tests. Okay? I didn't write any tests yet. I'm just kind of setting up IntelliJ for the tests. Any questions so far? Okay. Right-click, mark directory as, and bear in mind that I've got step-by-step instructions here, and there's also a lab this week that kind of works you through the step-by-step instructions. Okay. All right. So create a new class for testing. Name such that is the name of the class followed by test. So for example, friend test. And this is going to go in the test folder. So I'm going to right-click on the test folder or directory, the green one that we just marked, new class, and call it friend test. Because it's the friend class's tests. Yeah? Not crazy, that's what we're calling it. Great. So we're all set to start writing tests, mostly. Now, the problem is, remember how like with Python, we used like unit tests. We had to import unit tests, right? Remember that? Well, we have to do something similar here, but unit test was built into like your base Python. Java doesn't have something built into like the base Java for unit testing. But there is a like standard testing framework that we use called JUnit, right? That's what we call it. But because it's non-standard, we can't just say import JUnit. We have to do a little extra. Now, fortunately, that little extra is trivially easy to do, but I'm warning you that's what the next thing is. So for the sake of just setting it up, all I'm going to do is I'm going to write, now this is kind of weird, but it'll make more sense in a moment. I'm going to write @test. Is it uppercase T? I can't remember. Yes, okay, uppercase T. Yes. Now, if I hover over this, you will see that it's telling me I cannot resolve symbol test. And that's because I haven't imported like the JUnit stuff. But even more than that, this whole project doesn't even know what JUnit is to even import it. So we need to add something to like the class path. Now, it's even recommending something there. Add JUnit4 to class path. Do not do this. For some weird, raise your hand if you did that already. Good, good. I don't know why, I really don't know why. JUnit4 is the old one. We don't want that one. And it would create issues if we use JUnit4. And I don't know why IntelliJ by default wants to recommend JUnit4. I really don't know why. There probably is a reason, but so instead what I'll do is I'll go over here and click More Actions. And below it, you will see Add JUnit5 point whatever, whatever, whatever. The particular version number won't matter too much if yours doesn't match this. What matters is that you select the one with the 5. All right? So I'm going to say Add JUnit5. If you accidentally add JUnit4, you're screwed. You can go and modify the project. It's a pain in the ass. And if you come to office hours and you go like, oh, I accidentally added JUnit4, I'm going to say just start over. It's easier. Make a new project and start again. It really is easier that way. So yes, I want JUnit5. 5.8.1 in this particular case. Here, when I took this screenshot, it was 5.7.0. That's not going to matter. Just don't add 4. That's what I'm telling you. Okay? Add JUnit4 yet? No. Not that one. Cool? Now we're all set. I added it, and look, it's not unhappy. Well, it kind of is unhappy still for some reason, but it's because I have to import the class. Yes?
Not giving me the option to do anything.
Did you put it in a test folder? Put it in a folder that you mark test, and I think it might be smart enough to do it.
How do I get it into that?
Just make a new folder, mark it, and right-click on the new folder you make, and do like right-click new. If you're having a tricky time with it, come see me and we can get it figured out. It'll be easier that way. Any other questions? Cool, cool, cool. All right, so now all this means is, okay, now we're ready to start writing unit tests. And I know I gave you a bit of a song and a dance, but really think about the steps. Really wasn't too much going on. Create a folder, mark it as test, create your new test class in there, and add JUnit5 to the class path. All right. All right, testing the friend class. So I actually give you a friend test.java class, but I'm going to start by just copying some of these in here. I've got some examples. So here we go. I am saying @test. We mark each test method with this @test beforehand. And then I'm going to say, I'm going to follow that same convention we followed in Python. Method name, particular case, what I expect. It's the pattern I followed from before. The method name that I'm testing is getFirstName. There's no particular special case here, so I'm just calling this like general case, right? And then what do I expect? I expect it to return the first name. That is the pattern I want you all to follow when it comes to naming your tests. And then what am I doing? Let me take a step back. Let's look at the friend class. What do we want to test? Well, there's really not a lot to test. This class is basically data with accessors. We want to test our first name, get last name, get email, our toString, and our equals. That's all we have to test. There's not a lot going on there. So how do I test the first name? Make an instance of a friend, call getFirstName. Did it give you what it should? If it did, good. If not, we got a problem. Same with last name, same with email, etc. So friend, there we go. So I create a new friend with the first name QWERTY because why not? The name doesn't matter. And then I'm saying assert equals QWERTY and friend.getFirstName. So basically I call this and I'm checking that I get that. And you're wondering why is it saying that doesn't exist? Well, I'd have to import it there. Cool. So what this test is saying is create a new friend and check that the result, that QWERTY is in fact equal to the result of calling getFirstName on that instance. And if you want to run it, I could just say run that particular test. It takes so long to run this poor computer. You can do it. Come on. It's working on it. There we go. Look at this. Wait. Initiating tests. Okay, it's just started. Hey, one test pass. Great. Now, if I go back to the friend class, and for whatever silly reason, I change this to be like return the string first name. So this is clearly incorrect. Instead of returning the value of the field first name, getFirstName is always returning the string first name. So that's weird, right? That's obviously incorrect. This is a bug in my code. I don't know why I accidentally added quotes. I didn't notice. I write this test. I'm like, obviously this is going to work, but I'm a good programmer, so I'm going to write my test anyway. So I'm going to hit run on the test, and I'm going to see that it passes. But of course I'm not because I intentionally added the bug. And it's going to say, test failed. What? What's going on? Expected QWERTY actual first name. What? And then I go look at my class and I go, oh, that's weird. Let's put that back. That's what it's telling us. Okay? Now, this might feel kind of silly for such a simple class. And sure, I could make the argument that, okay, tests are going to be super important for more complex classes, but tests are super important for simple classes too, because you can make a stupid mistake anywhere in your code. Always write your unit tests. I never want to see any code that hasn't been tested. It's your job to show me that you've done what you can to ensure correctness before I even look at it. That's the point of these tests, is they convince yourself and everyone else that the code is correct. So let's write another one. Test void get last name general case returns last name. We'll make a new friend equals new friend. You know what? I'm literally just going to copy paste this. You could. You really could. I didn't bother. What he's asking is you can create like a method that'll, like a setup method, a method that will run before every test actually runs if there's something common between them. In this case, what's common between a lot of these tests is going to be the like, okay, make a friend with a reference variable called friend with these values. So we could do that, but not overly necessary here, but you're absolutely correct. So there we go. Now let's run all these tests. I'm going to run the whole test class. Actually, no, let's do one more where we do it with the email address. Get email, returns email. And we should get this back. Get email. I hit run on the whole class. It should run all of the tests. Let's give it a moment. There, great. All 3 tests pass. I'm happy. Cool? Now this didn't check all the methods yet. I'm not done. I just checked the accessors. Cool. Now, imagine for a moment I made this class mutable. I made the class such that I can go in and actually change the values of the attributes after it exists, okay, or the fields. When I say attribute, I mean field, I mean instance variable. They're all kind of words for the same thing. In Java, typically we call them fields, but you'll find a lot of variation elsewhere. It's a variable associated with the instance field. Lost my train of thought. Actually, before I carry on that train of thought, see how I use assert equals? There's a lot of other asserts. There's assert not equals, assert same, assert close to, or whatever. There's a lot. If I made this friend class mutable, which is entirely fine in principle, though we avoid doing it, and we say if you really want to make a new friend, or if you really want to change the values of that friend, tough, you can't, but you can make a new instance with the different values that you want. With this type of strategy, like think of how much tougher that class would be to test if we made the class mutable. We would need to test setters. We would need to test that the accessors work properly after calling the mutators, the setters, and so on. Like there would be a lot more to test. Mutableness is a pain in the ass. We like immutable things. It's good. So there's 3 tests there. Consider blah, blah, blah. Okay, yeah. Yeah, so, okay, the names, this is the convention I want you to follow. Like unit under test, like the method, the particular case, and the expected results. Like get first name, general case, return first name. Here's an example. Let's write a test for the equals. Now, I should write a test for a toString as well. But I'm going to skip that for the sake of time. You can go look at the example code that I give you to see what that would look like, but it looks like what you would expect. But let's do this one. No. Test equals, equal friend objects are equal. And I'm going to make another one. Equals unequal friend objects are not equal. I'm just making them not equal, and then I'm going to have to do assert not equals. I think that's the one I want. There. All right, let's run the whole class. I think we have 5 tests. So this is an example of the cases. So equals on equal friend objects and equals on unequal friend objects and their respective results. And they all passed. Good. Any questions about this? Now, we don't typically write the equals for the hash, the test for the hash code. Don't worry about that. In fact, give me 1 second. The way I'm doing these equal tests, they're sufficient for 162. But in reality, and I've got a warning here, it's a really bad way to check equality because equality is actually really hard to define correctly, even on such simple classes. And I'm not going to go into why right now. But there is a better way to do it. We're not going to do it in this class, though, because it's kind of hairy and requires a little extra knowledge. But this would check the hash codes for us, too. For our purposes, the tests like this are entirely fine. You had a question?
Yeah, would you recommend like writing these tests as you write your code?
Yes. Very good question. Do you write these tests as you're writing your code or after you've written everything? Everyone's different. Some people even say write the test before you write the code. Test-driven development. Because I don't need to know what the code looks like in order to know how it should behave, right? So you can do it whenever. Often it's better to write like a method, write the tests. Write the method and write the tests. Sometimes it's hard to write tests for a method because some methods are like inextricably linked that you kind of have to write more than one. And we'll see cases of this when it comes to the data structures. But do whatever works for you. But really the best way is method, tests, method, tests. Other questions? All right, I'll see y'all later.